Okay, so let's now talk about confidence intervals. Okay. Now remember that the theme of this course, right, is that we want to say something about the population parameters using sample counterparts, right? Okay. For example, what we have been doing so far is we have been trying to learn about the population mean mu x using the sample mean x bar, right? Now, we've learned about the sampling distribution of the mean, right? And the sampling distribution of the mean establishes a relationship, right, between sample means and population mean. Okay, and if you recall, that relationship is the expected value of all the sample means, which is the mean of all the sample means, is equal to the population mean. Okay, and then the sampling distribution of the mean also establishes the conditions under which sample means are normally distributed. Okay. Okay. Now notice that the sample mean x bar is a continuous variable. Okay, that means that if we have a sample and we calculate the sample mean x bar, the probability that that sample mean is equal to the population mean is always 0, right? And this is because for continuous variables, the probability that the variable takes on a particular value is always 0. Now that implies that having a sample mean alone is not very helpful. Okay, so our goal now, right, is to construct an interval that we can say with some degree of confidence that the interval contains the population mean, right? And such an interval is what we call a confidence interval. Okay. Okay. So the idea is, although there's a direct relationship between the sample means and the population mean, right here, having just one sample mean is not enough, right? Because it's extremely unlikely that the sample mean is going to be equal to our population mean. And so the idea is we want to have an interval that we can say with some degree of confidence, right, that it contains the population mean. And such an interval is known as the confidence interval.